Alright, so on this video we're going to calculate, this is a pivot in south central Nebraska, southwest Nebraska by Arapahoe. But as you can see, it's a pivot that doesn't, it's a cornfield that doesn't go quite completely around. The pivot doesn't make a full swing because it can't, because of the road off to the left that you can see here. And move some things there. But you can see a road that goes down along here, so they can't fit the pivot to go all the way around without moving the road. That's not going to happen. So we're going to calculate two things. I mean, one somewhat important to a farmer, the other very important. The first one, we want to calculate the arc length of this field. Okay? Arc length is this distance, I don't have the whole picture, but it's this distance around the outside. You can kind of see this road here. And it goes on around and comes out over here and into A, and it ends a little past C there. Maybe I can get down to the bottom of it. Oh yeah, we've got it here. And so it goes on. It actually goes just a little further. It goes to right there, in line with B and C. Okay, and we're going to get the arc length of that first. And then this, I'll connect B and A, and this angle between them is 100. This angle here, boy, that's hard to read. That angle there is 121 degrees. We'll just approximate it. It's 121 degrees, close enough for us. I'm sure I'm off a degree here and there anyway. Alright, so the formula for arc length is, well, first off, the formula for, and if it was an entire circle, circumference of a circle is 2 pi r. Alright, well, the radius of this particular field is 1,320 feet. 1,320 feet. So if this was an entire circle, it would be 2 times 1,320 times pi. Okay, so the circumference of this field, if you could complete the whole circle, would be 2640 pi. So a pretty large number. So 2640 times 3, basically. But we don't have the full circle. We only have part of it. And so a full circle goes around 360 degrees. So we're going to minus off the 121 degree angle that we found, which is 239 degrees. So this angle here is 239 degrees. So we have 239 degrees. Whoops. We have 239 degrees of the 360 degree circle. That's what part of the circle we're dealing with. And we're going to take it times that circumference we found if the circle were whole. So we're finding the ratio of the circle that's not whole. That's part of the circle. Anyway, so the arc length, and I'm going to call it S for arc length. So the arc length in this case is 239 divided by 360 degrees times the 2640 times pi, and I'm going to use the pi key in my calculator, but you can use 3.14. It's just going to be an approximation anyway. So it's about 5,506 feet. And granted, we could have some rounding errors in there. So, but that gives us a good idea. It's 5,280 feet in a mile, so to go around the outside of this field is slightly more than a mile. Okay? Farmers could possibly use that to calculate how much fuel they're going to use, things like that. Alright, so that's circumference. Now the area, and I'm going to switch to a new page so it's a little easier to see. To calculate area, so, well, first off, arc length, the formula for it, just to recap, is theta over 360, where theta is the angle that we're dealing with, and the last problem is 239 degrees, times 2 times pi times r. So the circumference of the circle times what part of the circle we're dealing with. Okay, area of the sector, and this would be more importantly what the farmer's looking for is how many acres that field is, and we'll find it in square feet first. that is going to be the angle divided by 360 times the area of a circle. So what part of the circle we're dealing with times the whole area of the whole circle. Okay, so in our case, again, we can just plug in the numbers we have. We know the angle is 239 degrees over 360 times pi times the radius, which is 1,320 feet squared. Okay, this number is going to be huge, probably in the 4 million range per square feet. So I'll just plug it in quick. You might plug it in with me to see if you get the same number, to make sure you're plugging it into the calculator right. I've noticed with students, the hardest part they have with this is plugging it into the calculator. And let's make sure I did it right. I'm going to do it twice. Times pi times, and again I'm using the pi key on my calculator, so depending on your calculator, it's going to be different. 3, 6, 3, 4, 0, 7. So, yeah, it's close. So this is feet squared. So that field is 3,634,070 square feet. So if we were going to have to maybe tile a floor, we'd have to buy 3 million tiles. I suppose this is comparable to the size of a big building like the Pentagon or something like that. Now we'll go into, we want to know acres. Square feet, that number doesn't make much sense. So I'm going to go to Google. And I use Google Earth, by the way, to get that picture. And I'm just going to type in that number, 3,634,000 square feet. So 3 million without the commas, 634,000, and I'm just going to round it, square feet. That's close enough. Hopefully I got enough. Square feet to acres. And there it is. Whoa! I got too many zeros. So 1, 2, 3. Let's see, 3,634,000. Oh, I got 2 more zeros. Let me get those off of there. There we go. So there is 3,634,000 square feet, 2 acres. And I'll recalculate that. So that's about an 83-acre field. I knew I made a mistake because they're not going to be more than 120 acres. So there's a quick thing you can do with Google, and pretty awesome tool. Use Google as much as possible. I'm sure they'd appreciate it. So thanks, good luck. You can also leave your answers in terms of pi. And there are, just to recap, the top one is the arc length formula. The bottom one is the area formula. And area of a sector. So when you're dealing with only part of a circle, that's what you have to do.